Basically, when you start a project, a structural project on CYPE software, first of the things that you would consider is to understand the codes that you're going to use during your design. So for this project here, it's an office building, a 3-story office building that is going to be built in Joburg. So knowing the soil condition, knowing the occupants, knowing the wind load in that area. So what we do, we start by configuring all the inputs that we need to take into account during the design. For example, for this building here, we used for concrete, we used Sub-0100 South Africa. Then we've got your steel, your cold formed, your rolled steel, all the loads have been taken care of. So for floor slabs, you can easily change to the concrete strength that you are working on with. I mean, then for all elements, then on the wind load, as you tick wind load, then you just come to this window load interface, whereby you just going to choose, you input the building tributary areas. It also shows there. Then you also need to try to understand the basic wind speed of the area where the building will be constructed. Then designed for service period of 50 years. On you can also check the direction of the terrain, wind load, I mean. Then for a 3-story buildings, for on CYPE is not of requirement to check the seismic loading, but to play on the safe side, on this building here, I had to choose to also check the seismic loading, checking my ductility in terms of reinforcement criteria, as well the fire check as well. So after putting all these values, here's the code of practice.
Simon, can I interject there? So
yes.
If you go back to the wind load,
Yes.
the wind loading, right? So if you don't
Yes.
know the properties of a wind loading, you are able to go onto that world globe, right? And then choose where you are, and it should then pick up the area, and then you're able to see
yes.
exactly what the wind speed is going to be.
Yes, that's correct. Yes.
Yeah.
You just press here on the globe decimal, then it will show you. You just choose where you want the building is going to be erected and all that. Then you just, by matching by interpoling, using the color in that area. Thank you very much for that observation.
Great. And then with the seismic loads, I mean, we've been having a lot of seismic activities in the last couple of years in South Africa. Do you think that is something, even for just a normal houses or a small structure, do you think it's time as the South African market that we start designing for seismic loads, whether there's a requirement or not?
Yes, that's correct. I think since we've been experiencing a high magnitude of earthquake, his South African partition in terms of structures, we need to take in consideration the seismic load. Even if you are doing a single story, but the other issue is that normally the way buildings that are constructed in South Africa, they normally ignore columns. And columns in a structure are the ones that play a vital roles in terms of the earthquake and all those things. So if we just concentrate on the brickwork, you just do your single story brickwork, then you do your roof and all that. Sometimes still you have not solved the issue of earthquake or a seismic, because you don't have like columns which can resist the like column resistance, earthquake resistant
Yeah,
structure.
you have more the
So-
wall bearing, the wall that are actually bearing the whole load on the wall itself. That's what's
Yes, so
happening, correct?
yes.
All right.
So normally, if you were to consider doing designing using RC columns, would also try to make our columns to be a seismic resistant structure. So,
Perfect.
but if say we doing the design, we want to consider earthquake or seismic on South African project or any, you just need to click on the wind loading. Then also it gives you this it lands you on this platform of whereby you can also check where is the building going to be positioned along the South African map.
For the wind
Then-
loads as well.
It's for, yeah, same as wind load, yes. So on earthquake, on seismic load, you just check where you are, the project is going to be constructed, then you know the peak acceleration of the building. But for this building in discussion, I chose 0.10 per meter seconds. So then soil type, you also need to not precisely, but you need to also understand the soil typing as you punch the values and the type of building. You need to also, by clicking these values here, you understand where it gives you an example, say agricultural building or what are you trying to, or not building. So for this project here, I chose type of building to ordinary buildings, not belong to the other categories like your agricultural and mall shopping areas and all that. Then you also need to understand the height of the building. You just need to punch it. For this case, the building height was 12-meter high. Then, yeah, you just basically check. Then the rest, as you chose the code of practice, it will automatically give these values.
It's very, very parametric method.
Yes. Then
Thanks for that, Simon.
okay. Then from after accepting the general data, after you've patched the general data and you are set to go, you click accept. Before you click accept, you can also check the additional load case whereby you've got to use the category of the building. What's the purpose of the building? So for this case, this building is a public area not susceptible to crowding, which is an office building. So you've got other options that you can filter HP the building occupants or the purpose of the building, whether it's residential, industrial, storage. You can just choose and
Why is this valuable for you?
it is valuable because we need to know the life load or the imposed loads that we're going to have on the building.
Oh, great. Thank you.
Yes. For example, for this one here on Sunstein 162 of the loading codes, in office would likely to have a life load of 2.5 kilonewton per meter squared to 3 kilonewton per meter squared. So that's very important. So say, for example, you don't choose this value, but you are designing for an office building. Then normally the program has you open, the program already gives you the option of domestic and residential areas. And this category here, it has a lesser load, imposed load compared to the office building. So this part here is very important when you're designing a building, when you're using CYPE structure to design your building.
Perfect. Continue.
Okay.
Perfect.
Okay. Then the rest of the load, here's we accepted the load is just going to add wind load automatic. Like here you can see these ones here, you don't need to punch any manual. It's automated as long as you've ticked the wind loading and the seismic loading, it will automatically give you the load combinations of each. Then on additional is the where normally if you want to check the shrinkage factor, for example, for this building here, I also chose to check the shrinkage of the concrete as it dries, or also because I also chose to check the fire resistance. So I need to take in consideration this option here. So I had to punch it manually. That's the
Interesting.
only load that I punched manual.
And
Then from
it's so
there-
important now to design for the fire resistance as well. And just to mention that one of the other software that CYPE offers is fire simulation. We've been having a lot of fires in structures in South Africa. I mean, even this morning, there is a fire in I think Pretoria, where the power substation just went up in flames. So so I think that helps a lot as well, right? To be
Correct,
able to
yes.
check the fire resistance while you are designing. And this is just going to take a few moments, and you've got all couple of stones for right, couple of beds with one stone.
Yes.
Correct,
yes.
correct, yes. No. Yes,
Right.
no, thank you for that observation. Yes, so by checking, one thing that CYPE helps on a lot about is that when you check your fire, you don't need to do a lot of things. You just need to click just a button, check fire. Then it will give you, for example, here, it checks without a fireproof code, to check whether that building will be resistant when in case of fire in that building.
So it's just
So
pick and
thank you very
choose,
much.
pick and choose some
Yes.
stuff, and that's it. Perfect.
Yeah, yes,
So let's
thank
see
you very
this
much.
model.
Okay. Then from after accepting the general data, after punching all the values, that the loading that you're going to take care of, the software will lead you to this page, to this interface whereby you need to have your column set the grid lines and everything. Just to put in mind that normally you don't need to start it from here. You can have an AutoCAD drawing, or you can have any DWG. It can be IFC, it can be AutoCAD, any imported. You can, if it's a DWG, you just come here and import your file. You look where the file is. For example, for this one here, it was from DWG drawings. Then I would come here and look for the project. I'm just going to show, I won't gonna upload it because the project is already, since
Yeah.
so for example, for this one here, it's in Chamdo. It's project Chamdo office. So I've done on the DWG drawings, I already set my grid lines, the column size and everything. I just click this and open, then it will upload. I won't gonna do that here now, but that's how
That's how
to
easy it
lend
will
me
be.
to this grid line. That's how I started.
Okay, so
Then
it's
from
an
there,
easy
I know
workflow.
yes. Then I double check my columns. Then I set the sizes, because if you are importing on the on DWG2, this one, it won't gonna take as a 3D model, a 3D structure, because AutoCAD or DWG works normally with 2Ds.
Yeah.
But if you are importing from IFC file, it will take a column as is. If you are doing it from Revit, it will import as is in 3D. You don't necessarily need to come and
place
do
it.
place it on this side. So
you've imported from Revit as well and done it automatically. You do both things.
That's correct. Yeah. So after doing that, you just you introduce your columns, or HP the grid line imported from AutoCAD drawings.
Perfect.
Done that, you proceed to the beams, whereby on beam definitions, you have your beams. You want to set up the beams. You've got your slabs. You also have walls on the wall option. For example, I'll also going to show you how I took in consideration the shear walls on
Can
this
we
building.
see the 3D model of this?
Yes. Here is the 3D model of
nice.
the structure.
So you did the foundation elements as well.
Yes. So after doing so, I've got I defined my beams, but most of these columns, the column position is going to be flat slabs. So I didn't need to introduce columns in every columns or in every grid line. So the grid lines that you can see are the only grid lines that are required beams. For example, from this grid line here, I needed a beam this side, a beam there, then the rest is just going to be a flat slab. Here's the 3D. If we can look at a 3D, on the first floor, I don't have any beams there. I just introduced them where I needed the most, where the beams are required, strictly required, I mean. Then after that, then I had to do, because the building is going to have a lift shaft. So I took that opportunity where the lift shaft is going to be, and it's well positioned exactly the center of the layout. So I had to divide by shear walls. How do you define the shear walls? You define shear walls by just entering walls. You go reinforced concrete walls. Then you just came here. Then you define your column position, your wall thickness. For in this case, for that shear wall is going to be 300 mil shear wall. Then you need to click there if it's a shear wall, because it's very important to tell the software that the same wall that you're introducing on the beam definition is not just a concrete wall, but it's a shear walls. Simply because you are telling the software to recognize or to distribute the percentage of loading for the entire layout. We know very well that the shear walls are very good when it comes to lateral loading, your wind load, your earthquake, and all those seismic loads. So I tell the software that I'm choosing these walls to be shear walls. For example, for this one here, I won't gonna introduce another any other, because we've already analyzed the job. So I'm just going to edit this one. So the walls, for example, shear wall 01 is a 300 mil thick from ground floor up to the second floor. Then I chose shear wall. I'm telling the software that when it carries the design, the structural design or the structural analysis of the project, it must assign appropriate load for the shear walls. If I don't do that, then it's just going to be taken, the wall is just going to be taken as normal wall.
Interesting.
Yeah.
And someone, I
Then,
see that you're also able to introduce masonry wall.
yes, that's correct. Yes. You can also introduce it, for example, for this one here. Yeah, you can do masonry walls by just clicking and introduce, for example, in South Africa, most double walls or we normal do them at 9-inch or 220 mil thick. So if you can, if you are using the normal brick wall, you would come here and punch values. For example, when you design, when you introduce it, you take it from the center. Here's the line shows. So you would want to split it in half, 110 on the other side and 110 on the other side. So you just introduce your own, and you can still also design. His normally is practiced in South Africa that you would find a building that doesn't have a column at all. It's just brickwork. They do foundation brickwork, then straight to the slab. So with that, with CYPE software, you are able to do the same type of design method or construction method by just introducing the masonry wall and putting your type of slab that you are considering to use, then you design, then it takes the design appropriately. And the other thing that I like about CYPE software is that when you do all the introducing of elements, structural elements, it also tells you that whatever that you are doing is not practical. So it's a very good point that I would recommend to any engineer to take in consideration when they use CYPE. How and
So it's a
trying
bit
to
like of
convince
a
them.
value engineering that the program's doing for you,
Yes,
finding
that's
the
correct.
best
Yes,
value in
because
the design.
yes, because we've got a lot of softwares in the market whereby it's a garbage in, garbage out. But with CYPE software, you are unable to do that. You need to know what you are doing. You don't need to be a software-driven person, but you also need to understand the basics by manual and transport it to CYPE. And
You gotta be a
that it
structural
helps a lot.
engineer.
That's correct, yes.
Good, good.
Okay, so yeah, we
Move
then
on,
proceed.
so we don't run late, because I know we have a few models
Yeah.
to show.
Okay, then on the edit, you come here, you do the shear walls, you just put values, the shear walls, you introduce the need. For example, I'm just worried if I can introduce one,
You
I will have
probably
to
will change the
redesign.
analysis, but if you could show
Yes,
us
I will have
first
to
the results, I think it will be better.
yes. So you just introduce like simply, but let me try. I will do a quick analysis after then. The, the shear wall, okay, let's say for example, I need to introduce a shear wall. I can easily put a value there, put a value there. Then the other issue that I would like to highlight is that normally, for example, for this case, if I were to choose, let me go to edit. If I were to choose this wall, this shear wall number 3, with its foundation type, if I were to put maybe any other type, foundation beam or strip foundation, it's going to be the program won't gonna analyze considering the 2 different factors because of the ground settlement. So for this case, I chose fixity. Reason being that if I had chosen any other type of foundation, for example, if I had put strip footing without soil or strip footing with soil iteration or foundation beam or other structure support, my foundation would clash with the column number 15. For example, here you see that it is the foundation is combined for the shear walls as well as the column 15. So if I don't do fixity, what's going to happen is that the column, the column base of column 15 would clash with the foundation on the shear walls. Therefore, the program won't gonna analyze it as it needs to do it fully. So it's also one of the factors that normally when you designing 2 structures that are close to each other, try to assign it fixity so that you don't run a situation whereby the software won't gonna recognize what you've introduced. Then in terms of introducing the shear walls, like I was saying, you just click there, and shear walls, accept, okay, give it a label. I would say shear wall 04, for example. Accept, click it, I can click it there. So shear wall. Accept.
And someone, while you're still busy with that, I think it's also worth highlighting that in your walls, you are also able to create wall openings for doors and windows as well. And also in the slabs, you are able to create openings.
Correct. Yes, that's correct. Yes. Okay. Then yeah, they then introduce your shear walls depending on the size and the layouts you are taking. You can do this also on the peripheral wall. For example, you would see other engineers using, for example, for this end, they would introduce a shear wall or maybe on this other end, depending with the design engineer on how you prefer to position his peripheral wall or shear walls in the building.
Interesting.
Just delete. Okay, yeah, to proceed on that, also, for example, if you are for this job specifically, we had we chose to do the design using flat slabs, meaning we try to optimize the design so that it doesn't become costly to the client. So we had to remove some of beams between other grid lines that I'm trying to view here on the 3D model. Then how do you do the flat slab? For example, for this one here, we just introduced this type of beam here. You would introduce it by coming to the beam definitions, then you click beam, current beam, you go the structure, then you choose this one, non-structure or limit beam, then you accept. Before you introduce, make sure that you click at which position are you going to start, are you clicking or you introducing the beam. Then you can put displacement. For example, for this displacement from here to there, it was 110 mil. So you would come here and say left and put 11 centimeters or whatever. It depends on how far your column will be to the edge of the slab. Then to also introduce the downstream beam, you would still on the same beam definition, current defined beam, come there. You can easily punch it there on the drop type beam. You also have an option to say below if you want your beam to be below the slab. But in this case, the beam is confined inside the slab on the upward part of the beam. Then that's how we introduced for the entire project. It's all about introducing your beams and your columns. I mean beams and
slabs.
And slabs. And also the other thing to consider is that if designing this type of structure, and you will not assigning any walls. And remember, this slab here is going to have walls, for example, from this column to that one. So what we normally do would consider the wall load. In South Africa, we take most of engineers, most of consulting engineers, they use 5.4 kilonewton per meter for a load-bearing walls or twin walls as we normally use this side. So 5.4 Newton, you come here and you just punch your line load, you put 5.4, example, if I were to put 5.4 kilonewton, then you just click where the wall is going to be. For example, if we've got a wall on this area here, you just click, you introduce your load, I mean.
Nice.
For this case, we've got walls on all the edges. That's why we've assigned 5.4 kilonewton per meter to all the edges, because all of these edges in the center, for example, this one here, we've got walls, and we are telling the software that we're going to do it flat slab, but at the same time, we don't want to put a beam. For example, I've got a single wall that is running from that edge to this one, and the other one from this edge to that one, that I don't want to put a beam. So what I did, I had to tell the software that on this line here, I've got a structure, or I've got a permanent load that is going to be here, of which its value is 5.4 on all sides. Then after doing so, you introduce your slabs, because in order for you to introduce your slab, you need to have your all the boundary, all your directions well introduced to the beams. For example, if you want to put a slabs on this position here, you need to connect these 4 columns with the beams. It's either you do a dropped, upstand, whatever type of beams that you are preferring to do. You do that in order that the software recognize that on that area, it's either you're going to put a slab or you're going to put an opening. For
So what you're
example,
putting is the type of beam, which is a flat beam, so that then you can put a slab over it.
slab, yes. Once you've introduced your beams, you come here, then
Panel
say
manager.
panel, enter, then you've got all options of slabs. For example, in South Africa, it's predominant used, it's a joint floor slab, but
Yes.
mostly known as a ribbon block slab. So that's a joint. You can click there, then you come, you define HP the manufacturer. Just put, for example, there's what we call S205. You want to put S205, then you edit, you've got a block size, then you just punch the value HP there, manufacturer specification. Then doing so, you are able to also assign whether you want on that area, you want put a single lintel or double lintels or triple lintels. Then you come introduce, but also if you don't want to do that, you also have the option of hollow core slab. The software itself does not have a library for hollow core, simply because this you can add, you can punch values, HP the manufacturer of that area. For example, in South Africa, we have what we call EcoSlab. So EcoSlab, they would give you a spec, or they would give you the sizes and specification that they have. You just come and punch by adding values, then you finish, then you can also introduce it. But for this project in case, we only consider using flat slab, but you can still choose any. We've got your wafer slab, of which is copper slab. Other engineers, they call it wafer. Others, they call it copper slabs. You can also do this that on this platform, on this interface. Then, but for this project here, we strictly went with flat slab, and you punch the depth of slab. For this project here, it was 20 centimeter or 200 millimeter thick slab. Then doing so, you also create this opening where you have a staircase. So the staircase, normally to create this opening, you would have a boundary beam that's going to limit the opening. Then you just come panel, then you delete that opening if you want to do so. If you don't want to delete the opening, you can simply introduce enter opening by just clicking there and enter. You choose enter return opening parallel to the beam, then you just click from the beam where the staircase will be resting to the other side where it started, or to the other side where the opening ends. But in this case, we've got this one, this opening there, this opening, and 3 openings. And also on our core or the shear walls, we've got the lift shaft that is going to be positioned there. So we had to create a boundary by just introducing a limit beam, then cut the area. Then we proceeded copying once you've introduced all the beams and the position and everything, you don't need to repeat on the following floors. You just come and copy. You copy loads, you copy beams, you copy tendon reflection lines, you copy and edit resource, then you just accept, you highlight all the layouts. If I were to copy this, just come, you highlight, then you right click, you proceed to the underflow, you copy if you want to do. I don't want to do it myself.
Oh, that's nice.
The project's
That's a good
already.
feature.
Yes, then you can simply erect, or you can simply model a 50-story building or a 100-story building simply by introducing in one layout or in one floor and copy the rest to the rest of the floors. In simply click, in less than 10 minutes, you've got your high-rise building modeled. But for this one here, we've got different position. For example, if you can see, I've got these walls here ends on the first floor. Or on the second floor, I don't have any walls within the inside the building, but on the edge or the facade. Then the other thing that we had to do is that the project, the client requested that the building be of 2-story, but at the same time, the roof is going to be it's either steel structure or timber truss structure. So for this one here, we just given a little bit of a background, but this is still to be developed more in terms of the roof type. Yes, the client still had to decide on what he's going to do. But what is good about the software is that once you've done the modeling and you want to introduce the roof, is what we call 3D integrated 3D structure, whereby you simply on the last floor you simply click integrate 3D structure, then you come, you assign, you write. For this case, it's a roof structure. It's a roof structure. It's a roof structure. So once you've click a new structure, then you assign the name, then it will give you option to click where you want to connect your steel structure with the building. So for example, for this project here, these are the connections where we want to connect the concrete to the steel roof trusses. So all this connection here that you can see. So these are the connections. But at the same time, say for example, you've done, then you accepted, you go work your steel structure on SYPE 3D. Then later on realize that you missed to put a connection. You can still come back and add the connection. You can add a connection, allow a new connection. You can come to the new connection, you click where you want to do, then it will give you an option to validate and put it together in one structure. For example, for this one here, after we did that, it gave us an option to interact with the SYPE 3D, from CYPECAD to SYPE 3D integrated structure. So there, we've got our structure, a roof structure, whereby we just assign the roof trusses the way we want to do. Then we simply took a quick analysis on the design. I must say, this is one of the best things that you would find, and I believe so far I've worked with a lot of softwares, but CYPECAD, SYPE 3D relationship is very powerful, and it helps in terms of integrating two different elements or two different type of construction into one, and you are able to analyze for example, the SYPE 3D in your CYPECAD. So once you've done this simple analysis on the structure, you can say you save, then you return to the main structure. Then the loads that you've analyzed on that side are imported to the structure, to the main structure. Then okay, that's where we have this kind of situation whereby you've got your SYPE two different SYPE menu that are integrated into one by using SYPE integrated 3D structure. Then when you do when you take up your analysis, you just click once, project analysis, including foundation or excluding foundation, then you analyze everything in one. You don't necessarily need to go back and design the steel structure separately. You can do all the design in one. For example, for this one here, we were able to do the SYPE 3D structure analysis of the roof truss into the CYPECAD. Then in terms of the columns, because for this specific project, we had a geotech that was favorable. It's the soil is favorable to do normal foundation. So we had to assign the column foundation. So, how did we do that? To all the columns, we we go to foundation menu and click foundation element, then you click new, then you choose type of the base, square footing, center rectangle footing, or eccentric rectangle columns. Then you choose, but for this one here, we had to choose a square column base. So just click there, you just click there, then click accept, then you click each and every column, then it gives you that option. Then also since at the beginning I assigned that the shear walls are fixity and the column also is fixity, I was able to combine the footing between the two elements, between the two vertical elements, the shear walls and the columns. By just clicking new, then you go mark columns, you select, then you accept, you click there, you click on the other side, then it combine the footing. I don't want to do that now because the project's already modeled, but it's a simply where you just click new, simply because this allowed us to combine, simply because I had assigned, I'll do edit here to show, simply because the shear walls, I assigned them as fixed elements. Then also the column is also fixed. So I was able to combine the footing to be, so that the design, the foundation does not
Clash.
overlaps into each other.
Perfect.
Then doing so, when you're done, you just simply click analysis, project analysis, accept. Now, because I've got a 3D integrated structure, it gives me option of steel and timber, this option, design option for the steel. Then I just accept, then I analyze the job. Then, I can quickly check the foundation. I just need to click once and be patient. Otherwise, if you double click at the same time, it will give you that error. So just do code check. Yeah, then it gives you everything. Pressure on the soil is verified, overturning of footings verified. So you can see that you've designed everything, it's verified here. So you can also view, if there is error, the software will tell you that maybe the shear in the footing is not all right, then it won't gonna be verified. You will have to adjust until it is verified, until it's all checked. So this one of the interesting parts that I like about the software. But at the same time, you can also check. You can also have a report, a full report for all the thing. For example, if you want to check
Job data.
forces, the combination that were carried on, you can click there and you view
interesting.
all the forces that were taken care of. Then it explains, and the values as well, the factor.
And someone, I think also what I like is that you are able to customize the report to include what you want it to include and not just share everything. And also I like the part where it can, on the report also, it will show you the exact calculations and the formula, and if it's if it will pass or if it's failing.
Correct, yes. You can, thank you for that observation. Yeah, there's a lot of things that you can do in the report. I had last year I had few students from University of KZN, of which they were required to design a building. Yeah, I think it was 10-story building. Then they were able to do their project very nicely, and they on the report they only focused on what they were required to produce. Then it was good. So it shows that the software itself, yeah, it takes care of structural as a whole. But also, for example, here, since we analyzed considering the seismic, you can also check the seismic forces and all that. But since okay, let's proceed to other.
Let's do the plans,
re-
and I think we'll
okay.
finish up with this. Let me see the type of plans that you're generating with this.
Okay, okay. Then from there you can go drawings, drawing selection. You check, for example, here you want to check the floor plans. Okay, let me just delete everything and start. Okay. So normally you would have normally when you click drawings, you would have a platform like this with no information. So what you need to do, you just need to click plus add. You check which element or drawing tab that you want to plot. For example, for this one here, I would say floor plans. And when you go there, you just check plane type, you configure. If you want to view the foundation layout or foundation reinforcement or a slab reinforcement, for example, for this one here, I'll choose longitudinal bar. It's not actual choosing, but you give option to every element that is needed in order for construction to proceed. So you've got the longitudinal bars, check the reinforcement layout, reinforcement, the quantity summaries, then you want drawings to be generated from floor 1 to floor 3. 0 is when you are also including the foundation. But for this one here, I would like to check the first floor up to the roof level. Then you accept. Then you do it again. Floor slab. You go transverse bottom. You do the same thing. 1, 2, 3. Accept. You do floor planes again. Top. You just filter what you want to view or what you want to plot or print. Then you accept all of it. Then here you've got the option to choose the type of title block that you would want to put on your construction sheet. For example, for this one here, you've got the site one, you've got there's 3 options that you can 2 options that you can choose, but the one that says empty, if you have already done your own title block as the office, because each and every office in South Africa, they would have the engineers, they would have its own title block. So CYPECAD also gives the option of uploading your own title block to this platform here. For example, say DWG. I don't remember where it was. Which I brought mine, but you can easily import any to this one here that you mesh, or if you've got notes that you have on AutoCAD, you can also do that. But at the same time, if you don't want, you just do with none. Since the job is going to be plotted into PDFs on AutoCAD or DWG format, you just go none, then accept, generate construction sheet, accept, then you've got your drawings.
Wow.
You can easily view. You've got rebars, you can go through
Wow,
them and
this is
check.
really good.
Yeah. Then we've got your bending sheet summary.
Wow.
On this software, on CYPECAD, it will show, for example, for South African market, they normally say Y10, not the diameter symbol 10. But in order for you to do that, it's very easy. You just need to go to drawings, then you choose drawings, you do configuration of the vertical, then you click there. Then you see here you've got symbols, is percentage, then you can delete, you can replace that with Y. Then you accept. You can also do the same on other sheets that you want to configure, and you accept. By doing so, you are telling the software that when it plots the drawings to AutoCAD, what is diameter, symbols. As we know, for example, for this one here, it will change. When it gets to AutoCAD, it will change this one to Y10
Okay, you show
instead of
that?
diameter. Yes, I can do that. Then from here, you just do print drawing. Then if you want to print each and every sheet on it's separate, but I would recommend to do it all in one file. Then you can choose where do you want to put. For example, this one here is in Jamdo. Then what you do, you just look for the file. It's the file. Files there. Jamdo office. There. Then you just name it floor slabs details. Then display and associate. If you click there, then you automatically, once you accept, the program will import to AutoCAD, then it will, the
Open.
AutoCAD will recognize, then it will automatically also open the drawings. You don't need to go back and so if we click here, we'll see what's going to happen. It's just going to recognize. AutoCAD will all open automatically, like now it's opening. So on this one here, it may still show centimeters, but if it's imported, once imported to AutoCAD, it will automatically change to millimeters. Then you'll have it properly on millimeters, even on the bending sheet as well.
All right.
Then, because of the type of shape code that we have in South Africa, I would recommend to any other engineer using the software not to be limited, but to add a column whereby you're just going to assign the shape code of each bar. You just look, for example, this one here, it's a shape code 35. So what I would normally do, I would is a double hook shape code 35, position 23, then I locate that position. Position 23, it's there, 28. Then if I add another column, I then assign next to it that is a shape code 35. Then in terms of bending, we've already assigned the length is from there to there is 4.9 meters. Shape code 23 there. Then you've got double hook.